Before we get started on sine, cos and tan, we need to do a quick PSA, public service announcement, with regards to a really important setting on your calculator. You need to have your calculator in year 11 in degree mode, not radian mode. You'll use radian mode in year 13 and I think the end of year 12. One of the modules has radians. There are two different ways of measuring angles. So you'd go into your Casio calculator here. We need to open up the main screen, shift, set up. If we go down here, we have angle. RAD means radians. We need it in degree. And it's done. And that's that, it's done. By the way, the sine, cos and tan buttons are here, and the inverse sine, cos and tan is reached by shift that way. Okay, end of. When I was a young guy, much younger than today, I inherited one of these things from my sister. A Casio FX82 calculator. She'd finished school, so I kind of got it. I knew what these buttons meant, but most of these buttons up here, I had no idea what any of them meant. Some of them, I don't think I've ever used that button on the calculator. I think it means, I'm not sure what it means, but it's the keys that we're interested in are these ones here, sine, cos and tan. And if you look really closely above that, sine -1, cos -1, tan -1. What does that actually mean? Well, here we've got the formal definition. So sine is the ratio, the opposite over the hypotenuse side. Cosine, cos is the ratio of the adjacent side over the hypotenuse. Tangent is the ratio of the opposite side to the adjacent. So it's an ordered ratio function. In the old days, we didn't have electronic calculators, so there was quite an industry for map makers and navigators and sailors to have these huge tables of sine, cos and tan, and the hyperbolic, I guess that means hyperbolic sine, cos and tan of those functions, and they're huge papers. And when I was your age, when we didn't know sine, cos or tan, sometimes we had to look it up in a table and we would find it. Now of course it's all on the calculator, but you still need to know what they are. So what does that actually mean though? Well, imagine I can draw and we have our right angle triangle here. So here's our right angle, and we have our angle that we're interested in, and we're going to call that theta, the Greek letter theta. So of course this is the hypotenuse side. This side, which is adjacent, which means next to both the theta and the right angle, is the adjacent side. And this side here, which is opposite the theta, is of course the opposite side. So when we use Pythagoras' theorem, we didn't really care about theta. And that's fine. If you've got two of the sides and you're wanting to find the other side, great. But what if you do need to find that side? Or what if you've got one of the sides and the theta angle? What do we do then? Well, then we use sine, cos and tan. We have these ratios of ordered pairs that we can use to solve theta. So sometimes it can be a bit daunting working out how to memorize which ones we're going to use. There are two mnemonics which are the most common, but they're also the best, which we'll do now. I'm sure you've probably seen this little mnemonic, SOH CAH TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. You will probably in your exam, if you're examined on this, get this little mnemonic actually in your reference sheet. I prefer this little mnemonic. It's not given to you, but you can work it out pretty easily. SOH, sine, opposite over hypotenuse. CAH, cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Really what it means is not so much sine, but sine theta, cosine of theta, and tangent of theta equals that. So why is this useful? Well, let's kind of look at some examples. Let's use sine, opposite over hypotenuse. You've probably seen this little mnemonic, SOH CAH TOA. It gets given to you if you sit the exam or you get examined on this. They will give you this little mnemonic. It means sine theta is equal to the opposite over the hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. It's just a nice way of memorizing it, but actually I find this model a bit better. You'll see why in a second. So if you look, it's exactly the same. SOH CAH TOA, and it gives you the ratios there. But why is it better? Okay. Let's take an example. Putting my keyboard down. Say we have a right angle triangle, and again, just pretend that I can draw. That's theta. Okay, and I have the opposite side and the hypotenuse side. I can now find theta using sine. Also, if I've got the theta and the hypotenuse, I can find the opposite side. If I've got the opposite side and the theta, I can find the hypotenuse. And the way we would do it is by using our triangle here. So say we've got, we're trying to find the opposite side. We don't know what the opposite side, but we've got the hypotenuse and we've got the theta. Well, the way we would do that is that we would sort of put our thumb over what we're looking for. So it disappears. And we know, therefore, that the opposite side is going to be equal to sine of the theta, whatever theta is, times the hypotenuse. Fair enough. Say though that we had the opposite side, but we didn't know what the hypotenuse side was. Well, we would come back to our triangle. I'm going to redraw it because it's a bit messy. So we're looking for the hypotenuse side. So we're going to cross that out. And now we can see that the hypotenuse side must be the opposite side divided by sine theta. We're not going to find theta just yet because it involves slightly trickier examples. But the question you want to ask is, okay, if it involves theta, which two sides are involved? Whoops, involved. Misspelled. And once we know what side is which sides are involved, what we're trying to look for, what we've got, then we can choose, is it going to be sine, cos, or tan? So if we've got theta and we've got the opposite side and we want to find hypotenuse, we would use sine. If we've got theta and we've got the opposite and the adjacent side, or we've got the opposite side and we want to find the adjacent side, we would use tan, because tan is the one that involves those three. So the bottom left hand side is really sine theta, cosine theta, tan theta, the angle. And we're going to do lots and lots and lots of examples. Let's just jump in and do a whole bunch of questions. So right angle triangle, which is this one here, is the angle is 30 degrees. Okay, 30 degrees. The hypotenuse side is 10 centimeters, and it says find the side of the opposite angle. Okay, so the opposite is this one here, and we're just going to call it x. So let's work out which one of these we're going to use first. Sine, cos, or tan. So what have we got? Well, we've got the theta angle and we've got the hypotenuse, and we want the opposite angle. So oops. So we want we've got theta, we're looking for the opposite, we've got the hypotenuse. Okay, we don't know what that is. So O and H belong to what? Well, O and H belong to sine, and we want to find the opposite, so we're going to cover up the opposite. So the opposite is going to be equal to sine theta times the hypotenuse. So x here, which is the opposite side, is going to be equal to sine of 30 degrees times the hypotenuse, which is 10 centimeters. And we would jump onto the Casio calculator. So sine of 30 is that, times 10 is that, so this side here is going to be 5. Fantastic. How would we find the adjacent side here? Well, we would probably just use Pythagoras. Next one, right angle triangle, the angle is 45 degrees this time. And the hypotenuse side is 20 centimeters. Find the length of the adjacent side. Okay, so we've got the adjacent side, we've got the theta, hypotenuse. We've got the theta, we're looking for the adjacent side, and we've got the hypotenuse. So let's call this side x. This is the adjacent side, because this is right angle triangle. Which of these are we going to use? Which one has A and H? Well, it's going to be cosine here. So we're wanting to find the adjacent side. We cover up the adjacent side because that's all we're trying to find, and then we would the adjacent side is going to be cosine theta times hypotenuse. So x, which is the adjacent side in this case, is cosine of theta 45 degrees times 20 in this case. And again, we just jump to the trusty CAH calculator, clear that. Cos of 45 degrees is that times 20. So 2 decimal places we'll say is equal to 14.42 centimeters. 2 decimal place. Next one, right angle triangle. As always, the angle now is 60 degrees. And the hypotenuse is 10 centimeters. Now, just be aware, before, this is pretty similar, it had the angle was 30 degrees, and we needed to find the opposite angle. I'm going to call it opposite now. The opposite angle. Sine of 30 degrees, so 2 times sine of 30 degrees is not equal to sine of 60 degrees. You can't one is not a multiple of the other. Okay. So saying that, we know that we're going to be using hypotenuse and opposite, so we know it's going to be sine, and we're looking for the opposite side, so we're going to put Dusty over the opposite side there, and the opposite side is going to be sine of the angle, which is 60 degrees, times the hypotenuse, which is 10. So sine of 60 you can do it in one fell sweep, but I just want to show you what it looks like. So notice that sine of 30 was 0.5, so it's not a 2-to-1 ratio, and we multiply that by 10, so 8.66 to 2 decimal places. That's our answer. Let's just do a couple more. And yet another one. So this time we have a right angle triangle, as always. The angle is 25 degrees. So obviously this is not to scale. And the side adjacent to the angle is 7 centimeters. So the adjacent side is, of course, the side that's between the right angle and the theta angle, and we're told that that's 7 centimeters, and then it wants us to find the length of the opposite angle. Alright, so what have we got, and what are we looking for? Well, we're looking for the opposite. We've got the adjacent. We've got the theta. So which of these three has opposite and adjacent in it? Well, it's going to be tangent. And what are we looking for? We're looking for the opposite side, so let's put Dusty over the opposite side. So the opposite side is going to be equal to tan of 25 degrees times the adjacent side, which is 7. I want to find some that are a bit different to this, but let's do this for now. So tan of 25 degrees maybe I'll do that again. So tan of 25 degrees 0.466 and change, times that by 7, 3.26. what? Well, 3.26 centimeters. That's our answer. Alright, one last one. This one is going to be slightly different. So this one is, check the right pen, the angle here is 35 degrees. So by the way, we'll always get in the habit of drawing the triangle. Even if you're like me and you have no artistic bone in your body, it always helps you sort of see what you're dealing with. And it tells us that the adjacent side is 25 kilometers, okay? 25 kilometers, and then asks you to find the hypotenuse side. Let's just call this H, and the opposite side, so O. Alright, let's find the hypotenuse first. So what have we got and what are we looking for? Well, we've got the adjacent side. That's 25. We've got that. We're looking for the hypotenuse side. And we've got the theta angle. So out of these three, which one has adjacent and hypotenuse? It's going to be cosine. So we're going to use cosine. Now we're looking for the hypotenuse. So now we're going to put Dusty over the hypotenuse. And the hypotenuse is going to be the adjacent divided by cosine theta. Because the A is above the C here. So the hypotenuse is going to be A, the adjacent side, which is 25, divided by cosine of 35 degrees. And we need to grab the calculator for that. So 25 divided by, and I'm going to put it in brackets just in these Casio calculators. You just got to be a bit careful. And we get 30.52. what? Or 30.52 kilometers. And that makes sense. I mean, if the adjacent side is 25, the hypotenuse side is the longer side, so it's going to be more than that. So that makes sense. Now the opposite side. Now for this one here, we are looking for the opposite side. So which of these has opposite and hypotenuse? Oh, it's going to be sine. So we're looking for the opposite side, and we've got the, so we're looking for, yes, we're looking for the opposite side, and we've got the adjacent side. Always go with the one you've got, and also because it's a nice round number. So we've got that. So which of these has opposite and adjacent? Well, it's going to be tangent in this case. So we're looking for the opposite side, so we're going to put Dusty up here. He's not moving. Come on. Here he goes. So the opposite side is tan of 35. I'd say the adjacent. Tan of 35, and now it's going to be times the adjacent, which is 25. And grab the good old calculator. Tan of 35, and that equals 0.700 and a bit. Times that by 25, and we get 17.51. I know we were given kind of whole kilometers there, but I'm going to do it to 2 decimal places, and it's in kilometers, and we're done. That's that.